issue. And in this variant review video, we are going to be discussing how to use internet searches to search for data on your variants. This method over, say, PubMed, OMIM, individual database searches a few years ago, and have heard the same from other genetic counselors. One of the really great things about using Google as a tool in this setting is that it can actually search the content of publications, supplement tables, etc., while PubMed does not search the actual content. It'll search abstracts, keywords, titles, and what. So I actually find that frequently, if not, almost all the time, I will get everything that is available on a variant in terms of published data, publicly available data on websites, case data, etc., through a Google search. So when you're doing this is that you need to search by all the different nomenclature that could be used for the variant. So we're going to look into the sodium channel variant here. So if I search, use all normal the variant, see what we get 9 results. We're going to wade through the results together in a moment. What we get when we use different search terms. So that gives us results. Now let's take a look if we just the 3-letter amino acid number and the gene. That gives us result. So that gives us 10. Single amino acid. That gives us 78. Some of these, as you'll see in a moment, will not end up being relevant. And for the C dot nomenclature, I usually try a couple different ways. But if we this way, we get 38 results. One, because I find there's often a lot of no will often put quotes. And that's down to 31 results. So for example, kind of an overview, you get different results depending on what nomenclature you use. And you may add additional nomenclature from here, or if you have a nonsense or a frame shift or a splicing variant, you really want to think back to historical ways that variant would have been named or numbered. So for nonsense, you want to be using ter and stop and x, etc. Also know for the gene in question, there's been any changing in the numbering system, and there would be a kind of exact variant with a different residue number. You'd want to be searching with that as well. For instance, in cardiology, when we're using the thyretin gene, TTR, there are 2 different numbering systems that even still to this day different labs use, so you want to search for both. Weeding through some results, we'll go the letter amino acid search. And you can see one of our first hits is actually ClinVar, which we may have already found on our own. See our other video about how to navigate and use ClinVar. The Clin entry, it is. Here we have another BI entry. The D. So we may want to get information from there. It may give us population frequency information. So we look through that. We're not going to go through how to kind of extract and interpret the data. We're really just working now on data gathering. What about link? So this link is to a database that we featured in our video on locus and gene-specific databases. It's a really great database for cardiac channels that compile published data on variants in those genes, and also has alignment with logs. You can see our logs of the SCN5A gene here. And you can also look up variants codon or the corresponding codon in those paralogs. So this is a great way to look at data on this variant. So here's our variant here, and there's a variant, the variant codon, and you can see publications listed on both of them, and then links out to PubMed, as well as some extracted data, what the type was, Brugada syndrome. So this, find a whole bunch of papers that I may want to then go look into. I often find that at least this area in cardiology, my searches will find me the data in the locus-specific databases, so I don't necessarily need to go to them independently, though that may not be true in all disease areas, so you'd want to be not familiar with it. It's the RAM database, and it pulls data from ClinVar, so it's redundant. This would be simple, but I could check it to double. You get lots of databases that are sort of aggregating data pulled from other sources, that are often not very helpful. So my guess is these four are not going to be very helpful, but I would want to go through each of them. So let's just take a look at this one really. Clarion, it looks like this is going to be a pull from ClinVar. So I go through each of these to make sure there wasn't anything useful. Sometimes you'll find surprising things like posters from conferences where you might only get the abstract, the Google search, or med search, or not even that. Let's go take a look at what we get with the single letter amino acid. So we get some of the ClinVar, that paralog database for the channels, with paper and circulating research, which I did not see in, so that's a really great example of where you find something with one set of search terms that you didn't find with another. So express intracellular localization of an SAN5A, it looks for the other variant that saw a specific database. It's not our variant, but it may be information that I'm interested in anyway. So I may pull this paper and go through it and see if it can provide useful data. Looks like there's information in a book, again, on this other variant. At the same time, I may or may not be interested in that. Again, papers, drug-induced Brugada syndrome in children, and it looks like our variant is in there. What it not actually is, you'll sometimes led by the Google preview. The paper for me, which is nice. And then I want to look through this and see what data it has in my variant. Let's do a quick search for my codon number. So it has a case. So I then go through this paper in detail. We have another video on that. So this identifies some more primary data on our variant. And again, this did not come up in our first search. And you can see it's because of the different type of nomenclature they're using. You would go through the rest of this and see what you find. Find some websites that are not useful, and ones that are, the more you do this, the more you get used to being able to is the recurring not useful ones. Like here's that SciCrunch entry again. That's just a ClinVar pull. So now we're based on this cDNA number. Seeing same entries. So this for the log database that we were looking at. So that's redundant with what we got from that database, but we might want to take a look to see if that's the case. again, drug-induced Brugada syndrome in children, drug-induced Brugada syndrome in children. I'm not going to comment. The circulation of cardiovascular genetics, I don't think we had a paper from there yet. So let's look at that. Sign in. And unfortunately, like most institutions, the way that my system works, I can't just sign in like that. I do PubMed or through my library. I need to know what I'm looking for first, and there's nothing indicating what the paper is here. But little tricks that you learn when you do a lot, copy and paste. Yeah, look at right. They're already cooked right after you put them in the oven. So if you take the URL, you can actually get the identifying information for the patient from the URL. So this gives you the year and the either the date or the issue, depending. So put that into your search. You'll be able to get more information. Paper. And actually gives me the information. And his classification of Brugada syndrome associated and long QT syndrome associated genetic variants in the SC5A encoded, So this is the paper. So I would go into my institution's link or and download that paper. But it's another paper that I had not found with the prior searches. So I continue to go through the rest of these search results. If you're particularly crafty with Google searches or Boolean searching in general, you can create a single term that will run search to get all of these different in the same set of search results. I personally kind of prefer to do it separately, but that's up to you. We would go about using Google to find data, making sure you use all of the relevant nomenclature for your variant, whether it's different systems, different legacy, protein, cDNA, if it's mitochondrial, etc. In another video, we'll go over how you parse the data that you find in those papers.